All right, we are on Unit 7, Day 2. A lot of yesterday was review from Math 2, where we looked at special right triangles and just like cosine, sine, and tangent. So make sure if you haven't seen that, you watch that. All right, we're going to start off with a warm-up today. We are on page 18, all right, number 11, and then we're going to do number 12 on the next page, just for review. All right, the image shows a circle with radius 5. So we see this right here. Draw a 180-degree central angle. All right, it will extend the diameter. So basically what that means is it just makes the diameter right here. All right, in the circle, what is the length of the arc defined by this angle? So we've talked about arc length. This is just review right here. We did this last unit. So what is the arc length defined by this angle right here? So think about this. This is, now, remember theta over 360. All right, arc length is times the circumference, 2 pi r, not pi r squared. That's the area. All right, so here, what is the angle measure right here? That would be what theta is. So in this case, it would be 180 over 360. All right, 2 pi, and then the radius is 5. Now, if you were thinking, well, wait a minute, isn't it just half? Could I put just half here? You could. It's just half of the circle. So you're welcome just to say 1/2 times 2 pi times 5. And so here, honestly, we can just plug the numbers in if we want. So if we do, let's see, 180 over 360, or you could do 1/2. 2, I'm not going to put pi in there. Now I'll just put 5. And so this comes out to be 5 pi, like that. All right, 5 pi. All right, now use this arc length and the radius to calculate the radian measure of 180 degrees. Okay, so let's think about this. The radian measure. Okay, we want to do radian measure of 180 degrees. Well, we've talked about in the past that, okay, degrees, how many degrees is a whole circle? 360. All right, and radians, okay, how many radians is a whole circle? Well, 2 pi. All right, a whole circle is 2 pi. All right, so here our degree measure of half was 180, like that. All right, so what's the radians? Well, how do I figure out the radians and think of this as just it's an equation right here. How do I solve it? Well, here, multiply by the denominator, 2 pi on each side. And when I do that, I get the radian measure. So here, when I do 180 times 2, and then I'll divide by 360, okay? I get 1, so 1 pi. So 180 degrees is the same thing as 1 pi radians, which we've talked about before. All right. Now, let's calculate the radian measure of 360-degree angle. Well, you should honestly already know this. 360 degrees is a whole circle. Well, how much is that in radians? We just said it, 2 pi radians. All right, and that's something you need to put in your memory bank and remember up there. Now, let's move on to page 19, number 12, for this as the warm-up. And if you want to try this on your own, you can. Match each polynomial with its end behavior as x approaches positive and negative infinity. Okay, note some of the answer choices are not used and some choices may be used more than once. Well, what does this graph look like? Okay, so with that's end behavior, I would start out there, just graphing whatever you have first. All right, so this is 6 divided by x minus 6. So when I start looking here, okay, and as x goes to negative infinity, I'm looking here. And as x goes to positive infinity, I'm looking here. Well, where is this value going to? And when we talked about this, I think it was unit 4, rational functions, look at it. It's laying down and it's barely touching what line right here? What line is that? That is the line x equal, no, not x equals, y equals 0, okay, the x-axis. All right, so in either direction, as x goes to negative infinity, it's going to x equals 0 or y equals 0. And here, this is also going to y equals 0 as x goes to positive infinity. All right, and what do you remember that is called? All right, this is called a horizontal asymptote. We also talked about horizontal asymptotes when the degree on the bottom is larger the horizontal asymptote is y equals 0. All right. Now, let's look at B right here. Again, you could go graph this yourself. So when I go graph it, 3x divided by x minus 6. All right, zoom out. In behavior, as this n goes to negative infinity, where is it going to? It looks like there's some line right here. Now, if you want to, zoom in, I'll hit the house button. What line do you think this is going to? All right, what does it look like it's going to? And you can stay here and play around with it. Well, let me help you out here as well. Do you notice the degree on top and the degree on bottom? Well, the degree on top is 1, degree on bottom is 1. So when they're the same, we can sit here and divide these leading coefficients, the 3 and the 1. So we get the horizontal asymptote to be y equals 3. And let's actually put that in there. If I put y equals 3, notice as I zoom out, it's not actually going to touch this line. It's just going to go really, really close to it. All right. And that one looks like it matches, and it does. If I had put my other answer choices, y equals 6 and y equals 0, you'll notice it actually crosses the graph. All right. And lastly, this one. Okay. We can graph the same thing. All right. Or you can actually just look at it. Really, it approaches the horizontal asymptote. And right here, okay, now I am going to graph this just to look at it. That's going to be the safe bet. But make sure you put 3x minus 18 in parentheses, and then x minus 6. All right, what do you notice about this one? This is a line. All right, well, let's start looking here. Did anybody notice anything about that? Do you notice that right here, a 3 actually factors out, and this makes x minus 6. When I factor out the x minus 6, what do you notice about this? It cancels. And what do you remember that is? That's a whole of the graph. So I have a whole at x equals 6. All right. And I'm left with the equation y equals 3. That's actually what you're seeing on here. All right. So right here, where is this going to as it goes out to each end? You're just seeing the line y equals 3. So as x approaches negative infinity, y is just going to 3. As x approaches positive infinity, y is going to 3. So actually, B and C go to this one. All right. Here, it appears the horizontal asymptote is y equals 3, but actually, it's not. This is a little deceiving because we could factor something out. All right. So make sure we're going to hit review, especially as we get closer and closer to our final exam. And your final exam is an EOC. So it is a state exam that you have to take. All right. So here we go. We're going to get to something, and it's going to look a little overwhelming at first. Something called the unit circle. Today, you've been doing things with the unit circle, unbeknownst to you, all right, and filling it in. And we're going to fill this in today, all right? Now, and we're going to be talking about this. All right, the first thing is, okay, unit circle, what do you think of when you hear unit? Okay, I think of 1. Well, the unit circle is a circle. The center is at 0, 0 with a radius of 1. Okay, so remember when we talked about circles in unit 6, we could write the equation to be x squared plus y squared equals 1, like that. All right, because we would do 1 squared right there. Okay, you can graph it in Desmos if you would like. Well, this is what this is right here, unit circle. It has things called degrees on here. It has things as the radian measures, which we've already talked about. And then there's points that we're going to fill in as well. This is something that we're going to develop today. All right. And you can look up different videos as well, and they can develop it as well. But let's start out with the degrees, because when you talked about circles, you probably talked about degrees first, just in your math career. So we always start on this axis right here, the x-axis. All right. And we start off with 0 degrees. All right. Now, 0 degrees right here. Okay. Well, how much is a whole circle? And I'm not going to fill these in like all in a row. We're going to jump around. Well, a whole circle we were just talking about is 360. All right. Well, how much was half of a circle we just talked about? Well, it was 180. So right here, half. That's 180 degrees. All right. Well, wait a minute. Well, what's half of that? Half of that would be 90 degrees. Okay. Well, think about this. Now, how much is each quadrant itself? Well, if that's 90, and this is 90 right here. So if I add 90 to 180, how much is that going to be? 270. I trust that you know how to do 180 plus 90 in your calculator. All right, so we got some of the degrees on here. So let's work on some other degrees. Okay, so look, this line appears to be in the middle of 0 and 90. So what's the middle of 0 and 90? Well, 45. So that means each part of this is 45 degrees. So when I add 45, all right, it's 45. Add 45 onto 90, to 45, and I get 90. Now add 45 more. Well, 45 more onto 90 is going to be 135. Now let's go add 45 more. I end up with 180. All right. Well, 180 plus 45 is going to be 225. When I add another 45, I get 270. And when I add another 45 onto 270, all right, and I already had 270 there. So another 45, I get 315. And when I add another 45, I get 360. All right. So I did all that by just cutting things in half. All right. Now, what about these other degrees? We'll look at it for a second. All right. Well, here, okay, and I'm going to go to a circle that's on, actually, yeah, I'm going to go to a circle that's on here for a second. All right. If I draw, and I'm going to come back to this one too. If I draw this right here, if you noticed here in this quadrant, I have two lines on the other side of 45s. Okay, it's a little kind of crazy right here. So let me draw it like this. I'm not going to draw the one in the middle. Well, what do you notice this is of? Do you see this is thirds right here? I've broken this into thirds. Well, if this is 90 degrees right here, and I break 90 degrees into thirds, so I take 90 and I divide by 3, each of these angles is actually 30 degrees. So that's 30 degrees right there. All right, so here we go. Let's do this. So this one must be 30 degrees. Well, guess what? Add 30 onto that, and I get 60. Add 30 onto that and get 90. 30 plus 90 is 120. 120 plus 30 is 150. 150 plus 30 is 180. 180 plus 30 is 210. 210 plus 30 is 240. 240 plus 30 is 270, which I already got. 270 plus 30 is 300. 300 plus 30 is 330. And then 330 plus 330 is 360 and brings me back around. So I've got all the degrees on there. All right. So these are all the degrees that you'll see on the unit circle when they refer to the unit circle. All right. Now, we've talked about, and I'm going to go to the bottom of this sheet, and I'll come back to the unit circle in a second. We've talked about converting radians to degrees, which we did just a second ago. All right. Like we talked about, the degrees is 360. All right. The radian measures, I'm just going to use R, 2 pi. And if they give us 30 degrees, what I can do is I can erase the D and I put 30. All right. And to solve for radians, if I multiply by 2 pi, I can get my radians. Now, I don't want a decimal. We want everything exact on this right here. So I'm just multiplying the numbers. 2 times 30, and then I divide by 360. Okay, now if you get a decimal like that, you want to hit math, enter, enter. Okay, and it changes it to a fraction, 1/6. All right. So 1/6 pi, but the way we write it is pi over 6. All right, so this is one way we can get it, and I could keep doing it, and I'll keep doing it so that you can see it. 45 over 360 equals the radians over 2 pi. So I would multiply by 2 pi. All right, so 2 times 45 and divide by 360. Okay, I end up with 1/4. You may see 0.25, that's 1/4. So it's a fourth of pi. All right, 60 degrees. Again, you can do 60 over 360 equals the radians over 2 pi, multiply by 2 pi. All right, 2 times 60 divided by 360. All right, you end up with 1/3. So I'm going to put the pi back in there on top. So pi over 3. All right, and 90 degrees. 90 over 360 equals r over 2 pi. Multiply by 2 pi. All right, 2 times 90 divided by 360. You end up with 0.5 or 1/2. So put pi on top. So half of pi like that. Now, if you notice, each of these degrees was actually on the unit circle over here. So I could put 90 is pi over 2. I could put 60 is pi over 3. I could put 45 as pi over 4, and I could put 30 as pi over 6. All right. Or I could do it a different way. So watch how I develop this. Now, and I could do the same thing and keep coming up with all the radian measures, but that's a lot of work. So watch how I come up with the radians of this. All right. Do you remember what we said? And so we're going to start off right here. We started here with the x-axis, 0 radians. How much is a whole circle in radians? 2 pi. All right. Now, this is just half of a circle. So if a whole circle is 2 pi, what's half? Well, what's half of that when I divide by 2? It's just pi. So 180 is pi. Didn't we see that in the warm-up? All right, now think about this. This is what I got so far, pi. Well, wait a minute. If I just take half of that, all right, take half of pi. When I take half, it's pi over 2. Didn't I just figure out 90 degrees is pi over 2? But this is an easier way. Now, right now, I've got this. But do you see how 45 is half of that? All right, so half of that, when I take half of this, it's going to be 1/4. So pi over 4. And think of this right here. When I take 1/2, all right, and I divide by 2, I get 1/4. You're just putting the pi on top. All right, now remember what we said about this right here. Okay, here, this is broken up. You're taking pi over 2 and dividing by 3. All right, so think about this for a second. Pi over 2. So I'm just going to do this right here. I'm just going to say, instead of pi, I'm just saying 1 over 2, and I divide by 3. I get 1/6. This is where pi over 6 is coming from. All right, but do you notice that this is, so if this is 1/6, do you see how this would be 2/6 right here? All right, but how does 2/6 reduce? It reduces to 1/3. And didn't we just figure out that this is 1/3 right here? So if you think of this as fractions, you can fill out all of these radian measures. All right, so here we go. I'm going to keep going with it, but again, I might jump around. All right, so let's think about this for a second. All right. If you think about the whole thing, let me go down to 270 for a second. Do you see that this is 3/4 of 2 pi if I go all the way from here to 270? So think about 3/4 of 2. So it's times 2. All right, that gives me 3/2. So the radians is 3/2 pi. All right, and it looks like that. All right, now let's go here. Now, I just want to do these center lines right here. I'm going to do them all in orange just so you can see it. All right. I'm going to do this one. These are all equal from one another. Now, I know the whole circle's 2 pi, but let's think about this. This is just pi. Well, how many sections do I have? 1, 2, 3, 4. Okay, so that's 1/4 right here. Okay, well, what is this? Well, that would be 2/4. Well, 2/4 reduces to 1/2. Okay, so therefore, this one's going to be 3/4. All right. This is 4/4, but think about this. 4 pi over 4, don't the 4s reduce and it gives me a pi? All right. Now here, moving on, this is going to be 5/4. All right. This down here would be 6/4, but I want you to look. Isn't 6/4? If I take a 2 out, I'm left with that. All right. It's 6/4. All right. So now I keep adding 1. I add 1/4, so that makes 7/4. And then this would be 8/4. But when I divide 8 by 4, doesn't it give me 2? All right. Now I just need the rest of these. Okay. Well, remember, and let me get this right here. Remember, let me get a different color. We broke this up into thirds. I'm going to do it with blue. Now I'm going to include this 90 because that's 1/3, 2/3, 3/3. Okay. 4/3, 5/3. Okay. You're splitting it evenly. I'm just not using those ones in the middle. But each one of these in the blue, I'm actually just adding 1/3. I mean, 1/6, I'm sorry. Because there's 1, 2, 3, 4, 5, 6, 6 pi or 6. So that's 1/6. This is 2/6. All right, but I already got that. That reduces. This would be 3/6, but that reduces to 1/2. All right, this would be 4/6, but think about it. 2 comes out of this 2 times. 2 goes in there 3 times. So this is 2/3 pi. All right, so 4/6, going back to that before I reduced it. This is going to be 5/6, but that doesn't reduce. This is going to be 6/6, but remember the 6's cancel. Right here at 210, this is going to be 7/6. All right, here, this is going to be 8/6, but look, 2 goes into here 4 times. 2 goes into here 3 times. All right. Okay, so let me go back to 8/6. This is going to be 9/6. Guess what? It reduces to 3/2. This is going to be 10/6. All right, but a 2 comes out, so that's going to be a 5. 2 comes out, that's going to be a 3, so 5 pi over 3. Now going back to 10/6. This is 11/6. That doesn't reduce. And then I'm back to 12/6, which reduces to 2. I filled in, this is the radian measures, and I also have the degrees of the unit circle. All right, so let's see if we can fill in a couple more things. All right, we have all these points. All right, well, what did I tell you about the radius? All right, the radius of a circle, of the unit circle, is 1. All right, that means right here, this point right here, the x value is 1, the y value is 0. All right, here, the x value is 0, but the y value is 1. Now be careful as we move around here. And right now I'm just hitting the axes. I haven't hit any of these yet. I'll do that in a second. All right. Here, be careful. The x is -1. The y is 0. And when I get down here at the 270 degrees, x is 0, but y is -1. All right. Now what's left are these points right here. Well, how am I going to get this? Well, remember those special right triangles that we talked about? Okay. 45, 45, 90, and 30, 60, 90. Okay, in these triangles, or in this circle, we can draw these triangles right here. Okay, like this. I'll start out with a 45, 45, 90. Because right here, with that orange thing, I can draw a triangle right here. All right, here, the length of this is our x value. The length of that is our y value. And we're going to get the point x, y. Well, here, this is always a radius of 1 right there. Okay, now think about this for a second. How am I going to find the sides? Well, we talked about this yesterday. In a 45, 45, 90, they're the same. And remember, this is one of those sides. I'll just call this x times the square root of 2. All right. Well, I would divide by the square root of 2. Okay. To find x. And when I do that, so x equals 1 over square root of 2, but we hate the radical in the denominator. So we would multiply by the radical 2 over radical 2. So radical 2, and then that makes 2. So guess what? This side is square root of 2 over 2. But in a 45, 45, 90, remember, each of the sides are the same. So this is going to be square root of 2 over 2. And this is going to be square root of 2 over 2. So the point is square root of 2 over 2, square root of 2 over 2. We do not want decimals. So that's the point here. Now, let me show you something. You don't have to do this every single time. This is going to make a 45, 45, 90 triangle right here. All right. And anytime with the x-axis, anytime we have these orange lines. All right. Guess what? It's the same point, except for what changes in this quadrant. Well, the x value is negative. So where you see here in the first quadrant, positive, the x and y are both positive here. All right. In the second quadrant, the x is negative, the y is positive. All right. Now, down here, you have another one. You can go ahead and put square root of 2 over square root of 2. All right. But what do you know about each of these? Well, both of them are negative. Both the x and the y are negative here. All right. And then here, square root of 2 over 2, square root of 2 over 2. What's negative? The y value is negative. All right. The x is positive. So they're mirror images of one another. Okay. And let's go do this triangle. Now, this is 30 degrees right here. You see this 30 degrees. All right. The hypotenuse is 1. Okay. Well, let's talk about this right here, 30 degrees. Remember, this is 2 times the side across from, I'm going to call it x. All right, across from 30. Well, that's pretty easy to solve. If I divide it by 2, I get x equals 1/2. So across from 30 is 1/2. So that's going to be 1/2 right here. All right, across from 60, which 60 would be right here. Across from 60 takes this one and multiplies it by the square root of 3. So square root of 3 over 2. So across from 60, square root of 3 over 2. So guess what this point is going to be? Square root of 3 over 2, 1/2. All right, so this one is square root of 3 over 2, 1/2. Well, notice this. This is just mirror image. That's going to be the same point, except for the x is negative. Mirror image is going to be straight down here. And if you notice, everywhere where there's a 6 right here on my radians, those are the ones where the points are the same. Now here, both the x and the y are negative. Oops, that should be 1/2. Negative 1/2. All right, and when I come mirror image over here, it's going to be right here. Okay, the x is square root of 3 over 2 positive, but the y is negative 1/2. All right, and lastly, this one right here. Okay, let's think about it. And I'm going to draw another circle right here, just so we can see it. It uses the same triangle, but this time 60 degrees is here. Well, across from 60 degrees is square root of 3 over 2. Across from 30 degrees is 1/2. So this point, remember the x comes first, 1/2, square root of 3 over 2. So really, it just switches the point right here. Okay, so 1/2 square root of 3 over 2. All right, 1/2 square root of 3 over 2, but x is negative. All right, down here, 1/2 square root of 3 over 2, but both of them are negative. All right, here 1/2, and then it's negative square root of 3 over 2. The y is negative right there. All right, so make sure we just developed this. I don't even have the whole thing memorized, especially if you are an honor student going into pre-cal and eventually calculus, you're going to have to know this. Now, I'm going to create a second video on how we actually use the unit circle in solving some of these problems that you have to do in Math 3. So hold on, watch the second video, but make sure you have an idea of how this was developed.